Okay, in this video we are going to look at how to convert denary, binary, hexadecimal and octal numbers between each of the systems. Now for GCSE you'll need to know how to convert between binary, denary and hexadecimal, and then for A-level you also need to know how to convert octal numbers. So denary numbers, let's start off with that. That's the everyday number. It's base 10, numbers 0 to 9. We use them in lessons and in life generally. Now, if I said to you, what is the value of 315, you would know that the 3 would mean 300, the 1 would mean 10, and the 5 means 5 units. So we don't need to know that. We can do that automatically. We can automatically work out what that value is. But we need to know this process because it's the same process that you're going to use to convert the next set of numbers. So binary. Binary is a base 2 system. That means there's only 2 possible numbers, that is 0 and 1. So how do we convert between binary and denary? First of all, we need to draw a table to help us. Now, this table here will help us to convert a 8-bit binary number. That means there are 8 individual digits in the binary number, and it will help us to convert it to a denary number. Now, the numbers along the top start with the number 1. That is the same as units for our normal denary system, but binary it'll be units. Now, it will go up in 2s, in the multiple of 2s. So 1, and it'll be 1 times 2, which is 2, 2 times 2, which is 4, 4 times 2, 8, etc., all the way to 1 to 8. This is important as that's the value of each digit in a binary number. So next, let's convert the binary number 0, 1, 0, 0, 1, 0, 0, 1. First of all, we add that binary number to our table, as so. From there, we can look at the values in our table. And we look at the values that have a number 1 underneath the header. So I can see there's a number 1 underneath the value 64, under the value 8, and the value 1. We simply add these numbers together to get 73. So the binary number 0100 1001 will equal 73 in our base 10 system. Note how I've put a little number 2 and a little number 10 at the bottom of those numbers. That shows you what the base is. So if it's got a little 2, it means it's binary. If it's got a little 10, it means it's denary. Let's look at another example. The binary number 001110000. I'll look again at the values where there's a number 1, and there's a 32, there's a 16, and there's an 8. If I add those 3 numbers together, it'll give me 56. So therefore, the binary number 01110000 will equal 56 in denary. So what about the other way around? We do the reverse. You start off with the table. So, if I wanted to convert 42 into binary, I just need to work backwards. Can I fit 42 into the 1 to 8 column? No. 1 to 8 is a large number, so that would be 0. What about 64? Again, it's a larger number, so that would be 0. 32 is a smaller number, so I can fit 32 into 42. Now I need to deduct this so I can work out the next number. 32 taken away from 42 will give me 10. So can 16 go into 10? No, it can't. Can 8 go into 10? Yes, it can. Subtract 8 gives me 2. And finally, 4 can't. Obviously 2 can go to 2, and that will give me 0, so the final number will be 0. I can double check that by looking at the headers. So 42 does equal 32 and 8 add 2. So the number 42 in binary would be 00101010. Right, I'm going to give you a few moments. Can you pause the video now? I would like you to try and convert these 3 denary numbers into binary and these 3 binary numbers into denary. Okay, let's have a look at the answers. So the answers are in red, so you can see if you got them correct or not. Next, we're going to move on to hexadecimal numbers. Hex is a base 16 number system. Okay, so that means there are 16 possible numbers that you can use. So we can use 0 to 9, but obviously we've only got 10 numbers to be able to choose to use. So we use A to F for the next ones. So denary 0 to denary 9 is the same as hexadecimal 0 to 9. But when you get to 10 to 15, we use A to F. So 10 will be A, 11 will be B, and so on. So how do you convert between the two? Let's convert the hexadecimal number 55 to denary. First of all, our table for base 16. We start with the units as ones, then we have 16, 256. So just like binary was a base 2 and it goes up with 2 each time, this is times 16 each time. So 1 times 16 is 16, then 16 times 16 is 256. It goes up times 16 each time. Now I put 55 into my table. Now I can see in the 16th column there are 5 lots, so I can do 5 times 16. And again 5 times 1. If I add all of that together, it will come up to 85. Let's try another one. A5 base 16 to denary. So again, I'll put it into our base 16 table. A is 10. 10 times 16 will be 160. I've got 5 in my units, so 5 times 1 is 5. 160 add 5 will be 165. Okay, let's do it the other way around now. Convert 50 into hex. So I've got a little 10 there, so that I know that's denary, our normal system. So number 50 into hex. So I get our base 16 table. And I'm going to do this the same way I did the binary. I'm going to work out, can 50 go into 256? No, it can't. Can 50 go into 16? It can 3 times. And then finally, can the units is 2. So 50 would be 32 to the base 16. One more example, 172. Can 256 go into 172? It can't. Can 16 go into 172? It can. And it can go 8 times. It can go 10 times. And then what am I left with? So 10 times 16 will be 160. Take away that from 172, that will give me 12. And I know C is 12, so I've got 12 units. So 172 to the base 10 will be AC to the base 16. Okay, a little bit more trickier, but just remember your tables. Can that number fit into the column? If it can, you then can add it up. I want you to try these 6 questions, convert the 3 denary numbers to hexadecimal and the 3 hexadecimal numbers into denary. Pause the video now and we'll look at the answers in a moment. Okay, so here are the answers. How did you do? 9 is just 9. 180 is B4. 68 is 44. 61 is 3D. 99 is 63. And 214 is D6. Okay, so now that was quite complicated, but this next section is easier. How do you convert between hexadecimal and binary and back again? First of all, it's very easy to convert 4-bit binary numbers, which is also known as a nibble, to hex and back again. So let's take our binary number. If we had a binary number of 00110110, first of all, I want to split it into 2 nibbles. And then I'm going to convert each nibble into hex. So I can see the first nibble is 2 and 1, so I know that's 3. And the second one has a 1 under 4 and 2, so that would be 6. So simply, the answer is 3, 6. So the binary number 00110110 is 36 to the base 16. Let's have a look at another example. 1011 0010. Again, I split it into two nibbles. I then look at the value of each one, so I can see a 1, a 2 and a 8, so 8 add 2 add 1 would be 11. Second one is a 2, and that's it. So 11 in hexadecimal would be B, and 2 it would be 2. So simply it would be B2. So that binary number would equal B2. Again, the other way round, quite simple. If I've got 1A, I write the number 1 as a binary number, and the letter A would be 10, so I write that as 10. I've just noticed a mistake. Let me just correct that mistake. 10 should be obviously that. Sorry about the mistake, just noticed it just now. Okay. So, if you're doing GCSE, you can stop there, that's fine. You do not need to worry about octal numbers. If you're doing A-level, you need to know how to convert octal numbers as well. So, it's the same process as before. Octal is a base 8 system, so that means each column is 8 times the previous one. So 1 times 8 is 8, 8 times 8 is 64. So what is the octal number 104 in denary? I'll write it in my table, 104, and I've got 1 lot of 64, I've got 0 lots of 8, I've got 4 units. So 64 add 4 will be 68. What about the denary 104 to octal? Well, again I need to go work backwards, so I think about 104. How many lots of 64 can fit into that? 1. That will leave me 40. How many lots of 8 go into 40? 5. So I've written 5 there. And then the rest will be 0, so I'll put a 0 into my units column. So the denary number 104 is 150 in octal. Okay, so a summary. We have 4 systems that we need to know for A-level and 3 for GCSE. Binary is base 2, octal base 8, denary base 10, which we use every day, and hexadecimal base 16. You just need to remember each base means how many different digits you can use. So when you design your table, if it's base 2, you're going to go times 2 each time, base 10 times 10 each time, base 8 times 8 each time, and 16 you times by 16 each time. I hope that helps with your converting between binary, denary, hexadecimal and octal. If you need any help, ask your teacher in the lesson. Thank you.